Welcome, everybody. Thanks for joining. My name is Kyle Fox, and I am a senior product manager at Algolia, sitting across our events and AI research teams. Today, we're going to be talking about one of the biggest challenges in machine learning, the cold start problem. This happens when you don't have enough data to effectively train AI models. It's something that many businesses struggle with, so I'll share with you how we tackled it at Algolia so that our customers can see value from day one. How many of you are familiar with this scene? Personally, I grew up in Seattle, Washington, where we have very cold winters. So unfortunately, this was all too familiar for me growing up. Now imagine you're late for work, you're in a rush, you come to find that your car is completely frozen over. You get in and you turn the ignition, but it's going to take at least 10 minutes to warm up before it can get on the road. Generally speaking, this analogy relates to the cold start problem in AI. To gain users, first, your AI needs to be smart. But to get smart, your AI needs to be used. So, as a business that builds and trains AI models, we often find ourselves in this paradox. Without sufficient data, the system can't learn. And without learning, it can't deliver intelligence or useful results to users. And without useful results, users don't stick around. And without users, you don't get the data in the first place. So, it's a vicious cycle that keeps a lot of AI products from getting off the ground. And it's the exact problem that we had to solve when building neural search. To give you the full picture, I have to tell the story from the beginning. And to do that, I want to give you a quick history lesson on Algolia. And stay with me, it'll all make sense in a second. So, if you didn't guess from the image, Algolia was first founded in Paris in 2012. Originally, it was a search API used for the internet. And for many years, we really focused on optimizing the performance of our keyword search engine as kind of the primary focus area. But over time, we released a number of different products and features to complement the search experience. Much of this really started in 2018 when we launched the search analytics and A/B testing features. To do so, we needed a way to track user behavior, which led us to build the Insights API for ingesting events. This then opened up a doorway for many other AI features across the portfolio, first starting with dynamic re-ranking in 2020, then on to recommend in 2021, neural search in 2023, and finally the AI search personalization system in 2024. And why do I mention all of this? Because all of these features require events to utilize them. Events play a very critical role within Algolia. And to explain them, I'll draw a parallel to a story you might remember from your childhood. When we search for things on the internet, we leave a digital footprint. And you can think of this like Hansel and Gretel waltzing through the forest. As they went off into the unknown, they left breadcrumbs to track their footsteps, hoping that the trail would help them find their way back. And you can think of events as little breadcrumbs. So for every search query, the user interaction leaves a breadcrumb behind. And this tells part of the story for why that user made an end consumption decision. And so if you look at this across the user journey from an e-commerce shopping perspective, first, the user starts by searching for a product. And that leaves a little breadcrumb there. When they get the results, they might scroll down, see something that they like, and click to see more details. Breadcrumb there. If it maybe tickles their fancy, they might add it to their shopping cart. And ultimately, they'll purchase the product at checkout. So for each of these steps within the user journey, we capture, store, and process these interactions as events. And this is what an event looks like. So you see in the payload, we capture a lot of different things from the event name, type, where it originated, what user, index, object, or query it was associated to, and the object's position in the result set. So this helps us internally to understand the interest and intent from the user. We use it as a signal for our machine learning models to optimize query understanding, ranking, and retrieval. And essentially, they're the basis for all of our analytics, A/B testing, and how we train our AI models. So as mentioned, this data is critical for any user to get value out of the Algolia platform. So now to how events are used. So as I mentioned, events are required by most of our products, including neural search, which is our semantic search engine. And if you don't know anything about neural search, essentially it's a vector-based technology. And vectors are mathematical representations of words, which are plotted in a multi-dimensional space. You don't have to understand all of this, but essentially what we do is we compare how close the vectors are And that tells us a little bit about the items that are similar in meaning to the query, not just in keywords. And this can be very powerful for long tail or ambiguous search queries. So take the visualization here. You see coffee right at the center, but around it, you can see clusters of words that are related to what coffee is. So things like tea, honey, chocolate, milk, all of these are grouped together because consumers often associate or buy them together. So if a user is searching for coffee, they might be interested in tea as another warm and comforting drink, or honey to sweeten their tea. Now, neural search understands the relationships because of the vector clusters, how they kind of combine to come together. And events are the way that we kind of determine this and make it smarter. So when a user clicks or adds coffee to their shopping cart, those little breadcrumbs are used to reinforce the relationships, which teaches the system that tea and honey are relevant recommendation. So this kind of captures the context beyond just the keyword association in a way that keyword can never capture it. So in the process of onboarding neural search, there's a few kind of key pieces here that we need to optimize the configuration. Because Algolia can be used in a variety of different use cases, a record that sits within an index can have dozens or hundreds of different attributes, things like title, description, price, image URLs, and a bunch of different metadata tags. Now, not all of those attributes hold much semantic meaning. So first, we need to determine the attributes that are most semantically meaningful and apply a weight that gives them sort of preferential treatment. So this essentially nudges the words closer or further apart in the clusters of vectors, which helps us to retrieve the right information for a given query. Now, neural search is a hybrid search engine, which means that it blends traditional keyword search with semantic matching. So we use something called the semantic blend weight to tune that balance. So for example, if the blend weight is set to zero point 0.4, that means 40% of the ranking signal comes from the semantic similarity and 60% still comes from keyword relevance. Now let's give you an example here. So you have a query like trendy retro Nike sneakers. And if the blend weight is set to zero point 0.4, that means that 40% of the ranking signal comes from the semantic similarity and 60% comes from keyword relevance. Now, why is this relevant or why does this matter? So with the query here, it's composed of something specific, which is the Nike sneakers, which is associated to the keyword search results. But then we have something that's a bit more descriptive. So trendy retro as sort of the vibe of what the person is looking for. So that comes from the vector-based technology. And when we set this blend, it kind of helps us to associate what the right balance is between the two. Now, let's have a look under the hood to see what happens in the neural search activation process. When a user onboards to the platform, we kick off this fully automated process to optimize the configuration. First, we start with gathering inputs. So we're retrieving your queries, records, and events. And then we simulate the search results. So this happens by replaying the queries in the index and seeing the ranking results. So this gives us kind of a baseline view of the performance of that query. Then we evaluate your results. So we calculate the relevance score to assess metrics like no results and to understand where we're adding value in this configuration. Based on that, we then tune the parameters. So these are the attributes that I was just talking about to favor the fields that matter most and setting the right balance between keyword and semantic. And finally, we generate what's called a neural expression. So this is essentially the configuration that we just optimize, which is applied to the settings, which kicks off a vectorization process. So essentially turning that index into a vector-based index. And voila. So now you have a custom tuned neural enabled index that's ready to be used. So let's apply this all together. We talked about this trifecta of data that I just described. So you have the queries, the records, and events. So with the records, that shows us what's in the product catalog. The queries tell us about what the users are actually searching for, and the events tell us whether the user was interested in the product. Now, each piece of information is important, and without it, then we can't really do our job effectively. So without records, well, there's nothing really for a user to find. And without queries, well, we wouldn't really know what the user is looking for. And without events, Well, we wouldn't know the results that were actually useful to that user. So depending on where you're at in your journey, you may be missing some of this information. And that's okay. We wanted to build a way for you to, for us to fill in some of the blanks if you were missing that information. But this is why events have really become the Achilles heel for AI activation, at least in the Algolia world. Oftentimes customers may have records and queries, but are missing events. And we can build the smartest models in the industry, or the most advanced AI features, but without events, they just remain idle, which is a bit of a shame, don't you think? And for many years, we in our team, we spent many years trying to simplify the event onboarding experience. But there still are a significant number of customers that haven't set up events or struggle with their event quality and the quality of their event implementation. And because of this, many people miss out on the platform's benefits. So for us, the challenge was clear. How do we give customers a faster, easier way to access our AI features? And this caused us to use kind of the scientific method to run experiments and measure the results. And with every innovation that's come over the years, typically it starts from working backwards from a common goal within a set of constraints. You think of somebody like Edison, living in a world without light. He worked tirelessly to find a solution to that problem. And I'm not saying that we're Thomas Edison here, but our goal was to make AI activation instant with the constraint of using events to do so. So this constraint forced us to think a little bit differently. If customers can't give us the data, could we create a way to simulate it using technology? And so this kind of caused our data science team to think through a few different scenarios, and to look at how others approach the problem. And they came across this study from some folks at the University of Waterloo. And what this study looked at was whether if large language models could be effective in filling the gaps with relevance labels when they were missing in search evaluation data sets. And the results essentially showed that OpenAI's models outperformed human judgment and data labeling exercises. And so for us, this was sort of the light bulb moment. If LLMs can reliably fill the holes in research data sets, maybe they could do the same for our customers when the event data was missing. So this kind of opened up an opportunity for us to conduct our own experiment, using LLMs to generate these relevance labels. So basically looking if the query and the record pair were relevant or not, and basically using the LLM to calculate those relevance scores and labeling the data set within the records. And we are actually quite impressed with the results. So the AI generated labels were 97% accurate from a relevance perspective, which gave us confidence in the approach that we were using. We had this with the relevant scores that we needed from the events, and we thought we can apply a similar logic using LLMs to fill the gaps for search queries. So when a customer onboards, they may not have search history, but they usually do have a product catalog of records. Now, using LLMs, we can produce synthetic queries based on the customer's records with a high degree of quality. And we've benchmarked this across a number of different models. This gives us the data that we need from the start, even before a customer goes live with Algolia. So going back to our activation workflow, we've added a few additional steps to make this easier for customers and accommodate any customer at any stage of their life cycle, whether they have enough data or not. So if they're missing queries, then we can generate synthetic queries to augment that early on in the process. And if they're missing events, then we use these LLM-based relevance judgments to fill in some of the gaps. And now all of that research has been wrapped together in a simple automated feature in the dashboard. So when a customer goes through the neural search configuration process, they'll essentially see this new event source. And if the events aren't available, we'll be able to automatically generate the missing data behind the scenes to get you up and running quickly. As we wrap up here, I wanted to share a few lessons that we learned and guiding principles. So first, constraint sparks innovation. So the missing events were initially a blocker for us, and that constraint forced us to get creative using synthetic data. And looking at the challenge as an opportunity, this was helpful for us for working through the challenges. Embracing experiments. So the research-led prototype that we developed became a customer-facing feature. And this is kind of a pattern that we see across the organization, working with our data scientists to kind of go out into the unknown, test an idea, and see what the results find. And not every experiment is going to be successful, but the ones that are really move the needle and drive innovation across the company. Time to value is the North Star. You got to think about the customer and how you can get them using your products as quick as possible. So, we found that customers are going to adopt faster when they see the value on day one, even before they set up all the plumbing and done all the work. So, if you can automate this on their behalf, they're going to be a whole lot happier. LLMs are your friends. They're not necessarily a replacement for live production data, but they can be quite effective for filling in the gaps. And beyond just the traditional use cases that you might think of LLMs, I think we're really just brushing the surface on the possibilities and what can be done with generative AI. Designed for modularity from the start. So we built this feature for neural search, but the same building blocks can be extended to all of our other AI features. So this is something we're exploring now to see how we can use synthetic data in a variety of different ways to get people up and running quicker. So always designed for things to be used in a reusable manner. And these lessons go beyond just the cold start problem. They're actually how we build AI products in Algolia in a practical, flexible way that delivers value to the customer. This is where you come in. If you're interested in using the feature, we're currently running a private beta for Elevate customers. We do plan on extending that and to a wider GA launch. But regardless, we'd love to get your feedback. So please reach out to your customer success manager and account team, and we'll make sure to get you enrolled. So thank you for joining. Hope that you enjoyed the talk. If you have any questions or ideas for what to build next, feel free to connect with me on LinkedIn. And until we meet again, thanks.